So what happened in the case of Fe plus 2 and Fe plus 3? You can say, what is the electron configuration first? You need to tell me. Of Fe, first Fe, okay. What will be the electronic configuration? There is a periodic table, no? Let's see the periodic table and say. From argon, say, hello.
Argon 18 4s to 3d6.
4s2, 3d6. Okay. And now you just need to observe what will be the N plus L value, means the energy of a cell. N plus L value, this will be small N plus L value of 4s and 3d. 4s N plus L is N plus L is 4 plus 0. Yes or no? For 3d,
Yes.
3 plus, for 3d, it will be
3
3
plus
plus 2, no? 3
3.
plus 2. SPDF.
3 plus 2.
SPDF. 0, 1, 2, 3. 3 plus 2 equal to 5. 3 plus 2 equal to 5. So more energy is a 3D. Electron will always can be pulled out or always can be eliminated from the lower energy,
4s.
means 4s. Means it will be easier. There another thing also, not by N plus L. Another thing is screening effect. Okay. Do you know about anything of screening effect? It's like screen. Yes, here in screen. Okay, parda. What is screening effect? Means there is a rule of SPDF, and it is observed that the D and F are more diffused. Diffused means it is more pulled towards the nucleus, and the you can see there is a third cell and it is a fourth cell. There is a rule to calculate the screening effects. We'll observe it in the next class. But you just need to remember that while taking out the electron, the 4s, the 4s electron will release first, then the 3d. Okay. This will we'll discuss by taking the screening effect in the next class. Now again, we need to write of Fe plus 2 and Fe plus 3. It is Fe, what is with argon 4s2 3d 6. For Fe plus 2, it will be, you say me, argon 3d6.
3d6.
And Fe plus 3,
3d5.
argon 3d5. Now you tell me which will be more stable between 3d6 and 3d5. I'm writing the cell. 3d5 versus 3d6. How the electron are arranged? Repeat it. For 3d6, there will be 5 half occupied, then it will be paired. For 3d5, all things half occupied. Which is more stable?
3d5.
3d5. So here, for our, this is plus 2 and this is plus 3, Fe plus 3. This will be more stable than Fe plus 2 because it will lead to a stable configuration. Now you say me about roasting of iron. Roasting of iron. That is Fe3O4. Now you say what is the electronic configuration? What will be the charge of Fe? Means oxidation stage of Fe. As O is minus 2, 4 into 2, 8, minus 8 will be divided by 3. And you see that it is not matching with either of the Fe plus 2 or Fe plus 3. You can see here or not. Hello.
Hmm.
What will be the oxygen state of Fe? Do you know how to calculate the oxygen state?
No.
Okay. In NaCl, as Cl is minus, NH plus. Okay. As it is minus oxygen state, NH plus oxygen state. In case of H2O, as oxygen is minus oxygen state, minus 2, it will be divided by both the hydrogen because it is the structure of H2O. It will be divided, so all those oxygen having H plus, singly ionized means H plus H plus. It have only one electron also. Let's forget about that. Then another cases sometimes. So here in these cases, this is oxygen 4, and oxygen likes to stay in the atmosphere in minus 2 oxygen state. So as there are 4 atoms and one atom having minus 2, so total negative charge is minus 8. It will be divided by 3 Fe. So 8 by 3. What is 8 by 3? 2.6.
6.
So can any atom stay in point oxidation state?
No.
So here we think that this is not completely same Fe. Some are Fe plus 2 and some are Fe plus 3. Okay. And it is living like AB2O4. If there are one Fe plus 2 and two Fe plus 3, so there will be 3 into 2 plus 6 and 1 plus 2. It will be 8. And it will fully satisfy the Fe3O4 value. So in roasting of iron, one iron is Fe plus 2 and two iron is Fe plus 3 and oxygen is minus 2. Why I say that here in this cases also, as the Fe plus 3 is quite more stable, it likes to stay in 3D5. So it will lead to the ultimately Fe3 Fe plus 3 oxygen state in air also. Other case also sometimes FeCl2 and FeCl3. Here also Fe is plus 2, Fe is plus 3. In air, if you leave here also, it will ultimately transfer Fe plus 3 because this is the most stable configuration. We are now out of the syllabus, so we'll stop this amazing fact of this nature. But see, you just need to remember that ionization energy which is lead to stable electron configuration, that ionization energy will be lower, means less effort is needed to ionize that molecule than the other one. Okay.
Okay.
Or should I say the Fe34 again? Or it's okay.
No, I get it.
Okay. Now some value we can place. There is a comparison between, but here look at here. It is going from 4s to 3d in this case. In the before case of calcium and scandium. 4s to 3d. Okay. 4s to 3d1 of scandium. Here in this case, if 3d is involved and 3 because it is the n is lower than 4s. So electron is the 4s is going fast. Means the ion it will be ionized fast than 3D. Okay. But in this case, in both these cases, you can comparison between beryllium and boron. Okay. Barium plus one and boron plus one. Ionization energy is lower for whom? You can comparison between ionization energy. First thing you just need to check the electronic configuration. Okay. Hello.
Beryllium
Yes.
2s2, boron 2p1.
Okay. Beryllium 2s2. You had 2s2 2p1. After
2p1.
ionized 2 plus 1. Here in this case, the S electron will not go fast prior. The P electron will go because they are having same N value. We also can see it by using the screening effect or the stacks rule. Here you just remember that if N is same, the electron will go from F, D, F, P, and S. Having lower energy, the electron removed. But in case of 4s2, 3D means Ns2, N minus 1D. Always the electron will go from S2 first, then the D. Okay.
Okay.
So in this case, after taking one electron, it will lead to which configuration? 2s1. But here, after taking one electron, it will lead to 2s2. 2s1 and 2s2. Okay. And which is more stable now?
Boron. Boron plus.
Boron plus one. So the ionization energy, IE, and here ionization energy. Which ionization energy will be lowered? Means lesser effort is needed to ionize. For whom? Boron and beryllium.
Boron.
Boron. So ionization energy for boron is lower than ionization energy of beryllium. Okay. You got it now? You just need to check out. In this group, first thing we suggest or the book suggests that the ionization energy will increases in this direction because the electron is going to the same orbit. But the proton is increasing, but the electron is going to the same orbit. As the radius decreases, the ionization energy increases. But there are some anomalies which we have discussed now between beryllium and boron, between magnesium and the aluminum are the same cases. So you just need to check the electronic configuration before giving any judgment. Okay, just think about the electronic configuration before giving any judgment, so that you just don't go so that the rigid rule that in this direction the ionization energy will increase, in this direction the ionization energy will increase. But here are some exceptions here. And why these are exceptions, I have said. There are no exceptions in chemistry. What people thought that there are exceptions and exceptions. But there are logic behind the exceptions. You just need to find what is the logic. Okay.
Okay.
Now I think you can do the ionization energy. After reading about the screening effect, you will get more knowledge about the ionization energy, I think. Then the electron affinity, or should we take some breaks?
We'll do it in the next class.
Restless. Okay. Do you get something or not? Are you getting something? Yes.
Yes, I'm getting a lot.
Okay then. Thank you. Okay.